At first glance, they looked too weird to fly, some too heavy, others too unstable, and a few just too ahead of their time. But each of these aircraft defied expectations and rewrote the rules of aerial design. From radar-evading shapes to machines that lift entire buildings, they weren't supposed to work until they did. This is the untold evolution of rotorcraft that shocked the world. Developed in the United States during the early 2000s, the Sikorsky X-2 shattered expectations of what a helicopter could be. With top speeds above 285 miles per hour, it became a milestone in high-speed rotorcraft innovation. Using coaxial rotors and a rear-mounted pusher propeller, it combined tight turn agility with extreme forward acceleration, redefining vertical flight performance forever. The X-2 was designed as an experimental platform to fuse rotor lift with propeller thrust. Its compact airframe, low-drag design, and fly-by-wire controls made it a flying testbed for technology still shaping military aviation. Though it never entered production, its influence is direct, especially on successors like the S-97 Raider. It became a blueprint for tactical V2L aircraft built for speed and control. By removing the traditional tail rotor and relying on coaxial blades, the X-2 achieved unmatched in-flight stability. The rear propeller pushed it forward, reducing aerodynamic drag while improving transitions between hover and cruise. Digital controls allowed hyper-precise maneuvers, ideal for environments where reaction time matters, urban combat zones, dense terrain, or rescue under fire. Its development costs surpassed $50 million, but that investment transformed the rotorcraft landscape. Every feature tested on the X-2 found its way into the next generation of aircraft. More than a prototype, it was a glimpse into the future, proof that when limits are ignored and science leads, the sky becomes a testbed for radical new ideas. And innovation can come in much smaller forms too. Built in the United States during the early 1960s, the Bell 533 was an experimental helicopter designed to test the limits of speed in rotary flight. It combined a traditional rotor system with fixed wings and jet engines mounted on each side. The unusual setup allowed it to reach speeds never before seen in a helicopter, earning its place as one of the boldest prototypes in aviation history. Engineers started with the airframe of the Bell UH-1 Huey, then added swept wings and two J-60 turbojets to reduce drag and boost forward thrust. This strange combination looked improvised, but hit a sophisticated goal, merging vertical lift with fixed wing speed. During test flights, it exceeded 270 knots, making it one of the fastest rotorcraft ever recorded at the time. Although it never entered production, the Bell 533 became a landmark in tiltrotor development. Its extreme performance and aerodynamic data laid the groundwork for future aircraft like the V-22 Osprey and the Leonardo AW609. The project proved that helicopters were not limited to slow speeds and vertical hops. They could evolve into hybrid platforms. The aircraft was never commercialized, so no official price exists, but a modern equivalent would easily surpass $20 million. Despite its rough appearance, the Bell 533 became a flying lab that pushed the science of vertical flight into uncharted territory. That spirit of modular innovation continued in the next aircraft, a Soviet coaxial design that looked even stranger, but proved just as brilliant. Developed in the United States, the Sikorsky S-64 Sky Crane looks skeletal, but it lifts like a giant. Built to hoist over 19,800 pounds directly from a central winch, this aerial crane moves water tanks, prefab bridges, and even disabled aircraft with pinpoint accuracy. Its appearance may be stripped down, but its lifting capability is unmatched in vertical logistics. Originally designed as the CH-54 for military use, it gained new life in the civilian world through Ericsson Inc. The company turned it into a critical tool for firefighting, disaster relief, and remote construction. Its exposed airframe, tall cockpit, and fixed landing gear allow precision hookups and tight maneuvering. This is not just a helicopter. It's a flying crane built for action, not appearance. It uses two Pratt and Whitney T-73 engines, each delivering 9,000 horsepower. Its top speed is 91 knots, with a maximum range of around 174 nautical miles. Despite its massive lift, the Skycrane includes a stabilization system that keeps suspended cargo steady even in crosswinds, making it perfect for high-stakes, high-risk delivery zones. Costing over $25 million per unit, the S-64 Skycrane is proof that raw utility can be revolutionary. Where conventional aircraft fail, it succeeds, lifting what others can't, going where others won't. With strength over style, this machine rewrote the rules of heavy lift aviation, making it one of the most capable aerial problem solvers ever created. Created in the Soviet Union in the late 1960s, the Kamov Ka-26 featured a modular detachable structure and coaxial rotors. By eliminating the tail rotor, it gained superior stability at low altitudes. This made it ideal for agricultural missions, aerial sanitation, and logistical support across remote and rural zones of Eastern Europe, where conventional helicopters struggle to operate safely. Unlike Western designs, the Ka-26 had external engine pods and a rear cabin that could be swapped in minutes. That allowed it to transform into an air ambulance, light cargo hauler, or crop duster with minimal effort. Its low operating cost and ease of maintenance made it perfect for short flights. Even decades later, this strange machine remains active in countries like Moldova and Ukraine. It used two Vedeneev M14V radial engines, each producing about 250 horsepower. With a top speed of 96 knots and a range of 278 nautical miles, it flew low but effectively. Its flight ceiling was modest, but ideal for civil and medical operations. In a world dominated by fast jets, this quiet workhorse proved that efficiency could beat raw power. The original price was just $25,000, around $120,000 today. The Ka-26, with its oddball look and rugged reliability, became a flying tool of the Soviet countryside. A symbol of practical, tactical genius in modular aviation, it laid the groundwork for repurposing aircraft into unexpected roles, just like the next machine, which turned from warrior to forest guardian. Developed in the United States during the early 2000s, the Piasecki X-49 Speedhawk is a high-speed compound helicopter that breaks the mold of vertical flight. Based on the UH-60 Blackhawk airframe, it features fixed wings and a rear-mounted turboprop-style thruster. This auxiliary propulsion enables speeds up to 243 knots, far beyond what traditional rotors can achieve alone. Its fixed wings reduce rotor load during forward flight, while the rear propeller provides horizontal thrust without compromising lift. This hybrid configuration gives the Speedhawk the ability to hover like a helicopter and cruise like a turboprop. Piasecki Aircraft designed it as a technology demonstrator, pushing the boundaries of what rotary wing platforms can deliver in both speed and mission flexibility. The aircraft uses a 4-blade main rotor but stands out for its smooth transition between hover and forward flight. Digital flight controls provide exceptional precision, allowing sharp maneuvers while maintaining stability. Test flights revealed aggressive yet predictable behavior, a rare trait among rotorcraft with exposed thrusters. The X-49 showed that agility and speed can coexist in one design. With a development cost of over $30 million, the Speedhawk never entered mass production, but it had a lasting impact. Its innovations directly influenced new high-speed rotorcraft now in development. The X-49 proved that helicopters don't need to be slow or limited by rotor physics. They can become fast, efficient, and radically reimagined hybrid machines built for future missions. Built in the United States during the 1980s, the Bell AH-1F Cobra Firewatch started life as a lethal attack helicopter. But its most surprising role came later, when it was reborn as a wildfire sentinel. Outfitted with thermal sensors, infrared cameras, and live streaming systems, it scanned dense forests, spotting heat sources long before flames appeared, even in total darkness or adverse weather. Originally designed for combat, the AH-1F was demilitarized and reconfigured for environmental missions. This Firewatch version operated across the dry, rugged regions of the American West. Its transformation proved that military-grade technology could be redirected to protect life instead of destroy it. By replacing weapons with optics, the Cobra became a symbol of peaceful innovation in aerospace. It used a Lycoming T-53L 703 turboshaft engine producing 1,300 horsepower. Capable of reaching speeds of 174 knots, it had a range of over 304 nautical miles. With a narrow frame and lightweight structure, it could maneuver through canyons, forests, and mountains, reaching danger zones that few aircraft could access quickly. The Firewatch conversion cost about $4 million. Officially retired in the year 2021, it left behind a legacy of strategic adaptation. The AH-1F Firewatch became one of the rare aircraft to cross the line between war and peace, serving the planet with silence, speed, and stunning precision. Up next, a combat helicopter that took air support to a terrifying new level. Built in the United States during the 1990s, the RAH-66 Comanche was the world's first stealth-focused attack helicopter. Its angular body absorbed radar waves, and all weapons were carried internally to minimize reflective surfaces. With a silhouette resembling the F-22 Raptor, it combined low noise, minimal infrared signature, and extreme agility for modern battlefield evasion. The project aimed to merge stealth and strike power for armed reconnaissance missions. Its airframe was built from advanced composites, with sloped surfaces and hidden components. Over 1,000 hours of test flight data proved its capability. Though canceled in 2004, the program laid critical groundwork for future low-observable rotorcraft used in covert and precision operations. It used two LH-Tech 800 turboshaft engines, each generating more than 1,300 horsepower. With a top speed of 156 knots and a range exceeding 278 nautical miles, it balanced stealth with performance. Fly-by-wire controls, internal sensors, and automation gave it precision never seen before in tactical helicopters. Although it never saw combat, each unit would have cost over $45 million. Despite its retirement, the RAH-66 Comanche left behind an invisible legacy that shaped modern military aviation. Today's low-signature helicopters owe much to its design. Silent, smart, and lethal by design, it was proof that in future warfare, the most dangerous threat might be the one you never see. Designed in Russia, the Milimi 35 P Super Hind is nicknamed the Flying Tank, a blend of heavy attack helicopter and armored troop carrier. It holds up to 8 armed soldiers and fires anti-tank missiles, rockets, and guided bombs. The P stands for Pushka, cannon in Russian, and this variant includes a GSH-23L gun, ballistic cockpit armor, and night sensors for full-spectrum battlefield dominance. Its tandem cockpit, raised air intakes, and combat camouflage give it a menacing presence. Used by Brazil, India, and Angola, it's proven highly adaptable to extreme environments. The Brazilian Army deployed it in the Amazon for both combat and evacuation, taking full advantage of its range and rugged performance. The Super Hind isn't just offensive, it's tactical support and protection in one armored platform. Powered by two Klimov TV-3 engines generating 2,200 horsepower each, the helicopter reaches speeds of 169 knots with a range of nearly 350 nautical miles. It remains stable even under fire and operates from rough landing zones. The Mi-35P combines speed, armor, and raw firepower into a compact aerial assault system built for modern conflict. Priced at over $36 million, the Super Hind delivers heavy-duty air power in a rugged, flexible package. More than a helicopter, it's an airborne fortress that brings battlefield versatility wherever it flies. A true example of Russian combat engineering, it proves that function and force can fly together. And now we switch from firepower to firelifting, with a machine built to haul the impossible. Equipped with two tilt nacelle engines at the wingtips, the Leonardo AW609 blends helicopter-like vertical lift with turboprop-level cruise speeds. Originally developed in the United States in the late 1990s and later refined in Italy, this hybrid aircraft can take off vertically and transition to high-speed forward flight. Its silhouette resembles a sci-fi spacecraft, attracting attention at air shows and future mobility expos. After Bell's early prototypes, Leonardo took full control of the AW609 project. This transatlantic partnership combined technical expertise from two aviation giants, resulting in a multi-mission tilt rotor. It serves high-end executive transport, medical evacuations, law enforcement, and special missions, becoming an icon of the advanced air mobility class and the next generation of vertical aviation. Powered by two Pratt & Whitney Canada T6C-67 engines, each producing about 1,900 horsepower, it reaches speeds up to 270 knots. With a range of 650 nautical miles and a ceiling above 25,000 feet, it carries up to 9 passengers in missions demanding flexibility, reach, and vertical mobility in one aircraft. Still undergoing certification, its estimated price exceeds $25 million United States dollars. First flown in 2003, the AW609 already signals a transformation in how vertical flight is understood. Its futuristic design and advanced engineering highlight a new class of rotorcraft built for long-range precision, urban access, and executive comfort, both in remote locations and dense cityscapes. Born in the United States during the early 2020s, the Sikorsky CH-53K King Stallion redefines the idea of airlift dominance. With 3 General Electric T4000 engines delivering 7,500 horsepower each, it carries payloads of over 35,000 pounds. It can transport up to 55 fully armed troops over 450 nautical miles with no external support. Designed for the United States Marine Corps, the King Stallion incorporates fly-by-wire controls, landing assist sensors, and composite rotor systems. Its reinforced airframe was built to survive heavy fire and punishing terrain. Compared to its predecessor, this model delivers greater payload, better endurance, and smarter automation, making it a top-tier option for high-intensity battlefield logistics. Following years of testing, it entered service in the early 2020s with unmatched expectations. Its modular systems allow fast upgrades and reconfiguration, ensuring long-term operational value. Nations like Germany, Japan, and Israel have expressed serious interest. The CH-53K is more than a helicopter. It is a logistics platform with the mindset of a battlefield asset. Priced at over $95 million per unit, it is one of the most expensive helicopters ever built. But every dollar supports unmatched performance and reliability. The CH-53K King Stallion is not just a transport machine. It is a game changer in military mobility, turning airlift into an offensive tool. And as we've seen, innovation thrives where form meets raw, engineered purpose. Developed in France in the late 2010s, the Airbus H160M Guépard is part of a bold push toward modular military aviation. Powered by 2 Safran Arano engines delivering over 1,300 horsepower each, it reaches cruise speeds of 139 knots. Its 5-blade boomerang-shaped rotor minimizes vibration and noise, greatly improving performance in tactical operations. Designed as a universal platform for the French Army, Navy, and Air Force, the Guépard replaces aging fleets with one standardized solution. It handles a range of missions: naval patrols, medical evacuations, special ops, and close air support. This unified strategy helps reduce logistics complexity and streamline maintenance across all branches of France's armed forces, making it a modern icon of European defense integration. The aircraft holds 2 pilots and 5 armed soldiers. With fly-by-wire controls, a digital cockpit, and Thales avionics, it offers cutting-edge control with low weight and excellent agility. Compact enough for naval decks and urban landing zones, its short turnaround times enable rapid deployment. The Guépard's adaptability, tech stack, and speed make it a perfect tool for high-mobility joint operations. Each unit exceeds $40 million, an investment justified by its ability to replace multiple aircraft types. The Guépard is not just a helicopter, it is a strategic move toward fleet consolidation, future-proof engineering, and international cooperation. While France leads the way, other NATO nations are already considering adoption. The next aircraft, though, takes heavy lift to a whole different level. Built in Japan during the 2010s, the Yamaha Fazer RG is an unmanned aerial vehicle that looks more like a flying motorcycle than a helicopter. But behind its compact frame lies serious technology. Designed for precision agriculture and environmental monitoring, it operates via remote control or autonomous flight, covering wide fields, spraying crops, and inspecting hazardous zones with ease. Its short missions are supported by up to 90 minutes of flight time, stabilized by GPS and a digital gyroscope. The RG-2 handles rough terrain and moderate winds, making it ideal for remote farms, rice fields, and mountainous areas. Its success in Japan expanded to pilot programs for volcanic surveillance and crop protection, proving its value far beyond agricultural use. A single-cylinder combustion engine delivers around 20 horsepower, giving it a range of 30 miles. Onboard systems include electronic stabilization and dual navigation backups to ensure safety and flight precision. It's easy to operate, affordable to maintain, and tailored for small-scale farmers and research groups needing reliable aerial coverage in challenging environments. Priced at about $120,000, the Fazer RG-2 shows that aviation innovation isn't always about scale. It's about solving real problems with smart engineering. With successful deployments across Japan and interest from South Korea, this lightweight UAV blends artificial intelligence with field-ready practicality, redefining the future of micro-air mobility in civil and ecological missions. Each of these rotorcraft redefined what flight could be. Strange in form, but brilliant in function, they remind us that aviation thrives on bold ideas. If this blew your mind, hit the like button, subscribe for more futuristic aircraft, and share it with fellow aviation fans. What was your favorite? Drop it in the comments and join the discussion below. Watch the videos that appear here on the screen and stay with us. Bye-bye.